Previous lectures we have studied about DFAs and NFAs. So in this lecture we will be studying about how to convert NFAs to DFAs. Alright, so let's get started. Okay, so we say that every DFA is an NFA but not vice versa. That means that every DFA is an NFA but every NFA is not a DFA. Alright, but there is an equivalent DFA for every NFA. That means every NFA can be converted to an equivalent DFA. Okay, so we have two statements here, but how do I justify this? In order to justify this, let us do it this way. When we studied about DFA and NFA, we studied that DFA is defined using 5 tuples, NFA also is defined using 5 tuples, and all the tuples in DFA and NFA were same except for one of the tuples. And which was that? If you remember, it was the transition function del. In case of DFA, what was the value of del? Del was a transition function that maps Q cross sigma to Q, right? This was the transition function for DFA. And in case of NFA, what was the transition function? In case of NFA, the value for del was Q cross sigma to 2 power Q. So this was the only tuple that was different in DFA and NFA. All the other tuples were same. Now let us observe these two equations and try to figure out how can we justify this statement. So if you look carefully, you can see that Q cross sigma to Q, this part, it is contained in this part, Q cross sigma to 2 power Q. Q is also a part of 2 power Q. I hope you're getting what I'm saying, but 2 power Q is not a part of Q. So this, it is already contained in this. So we can look at these two equations and say that every DFA is an NFA, but every NFA is not a DFA. Alright, but there is an equivalent DFA for every NFA, but there is a way we can convert every NFA to a DFA. That means we can make them equivalent. There is a way to convert every NFA to DFA, and that is what we are going to see in this lecture. Alright, so to demonstrate this, let us take a simple example. Okay, so we have an example language here, L, which is the set of all strings over 0, 1 that starts with 0. So let us design an NFA for the language which accepts the set of all strings over 0, 1 that starts with 0. So here our input symbols, sigma is 0 and 1. So let me design the NFA for this. So in order to do that, we have a starting state which is state A, and A on getting input 0, I will send it to the next state which is state B, and my condition is that it should start with 0. So A on, this is the first input I get, A on getting input 0 goes to B, and B should be my final state or the accepting state. And in B, after that, whatever I get, I don't care whether it is 0 or 1, it stays in B itself. So this is the NFA. This is the NFA for L. Alright, so how do we know it is an NFA? A on getting input 1, I did not mention where it goes to the that configuration. So that is not mentioned means it is a NFA. Okay, now before proceeding, let us just draw the state transition diagram for this. I am trying to draw the state transition diagram for this NFA, and in the state transition diagram I will have my inputs here 0 and 1, and here I will have my states A and B. Okay, now let us fill up this table. A on getting input 0, where does it go? It goes to B. And A on getting input 1, where does it go? It goes nowhere. It goes to phi, right? Phi is the dead configuration. So remember that this det configuration in NFA will be, what will be its equivalent in DFA? In DFA, the equivalent of det configuration will be a det state or a trap state. So keep that in mind. And let's come to state B. B on getting input 0, where does it go? It goes to B itself. And B on getting input 1, where does it go? It goes to B itself. Okay, now let us try to convert this state transition diagram for this NFA to its equivalent DFA. Okay, so what we are trying to do is make the DFA. So the state transition diagram for DFA, how would it look like? I'll again draw a table here. Okay, and in my table, what will be the things I have? I'll have 0, 1, which are my inputs, and I have my states A and B. Okay, now let's see. Let's look at this table and try to convert it into a DFA. So A on getting input 0, where does it go? It goes to state B. And A on getting input 1, where does it go? It goes to phi. Phi is a det configuration in NFA, but in case of DFA, we cannot have a det configuration. This should be replaced by some kind of state. And what is that state? I will call it state C, and state C is my det state. It is the det state, also known as the trap state. Okay, and B on getting input 0, where does it go? It goes to B itself. And B on getting input 1, it goes to B itself. Okay, now is it complete? It is not complete. Why? This is a DFA, and I should mention clearly about each and every state where it goes on getting particular inputs. I have mentioned about A and B, but here I have a new state in this DFA, and that is state C. So I need to mention about state C as well. And if you remember, whenever any input comes to the det state, it stays in the det state itself and it does not go out of that. So C on getting input 0 should stay in C itself, and C on getting input 1, it should stay in C itself, because C is my det state or trap state. Now this is a complete state transition diagram for my DFA. Now let me draw the diagram, state diagram for this. Here I should have A and then B. My final state should also be B, right? And in here I have a extra state, that is state C. Okay, so A is my starting state. A on getting input 0, it goes to B, right? And A on getting input 1, it goes to C. Should go to C on getting input 1. Alright, and B on getting input 0 and 1, it stays in B itself. It stays in B itself on getting input 0 or 1. And let's come to state C. C on getting input 0 and 1, it stays in C itself. Okay, so here I have the complete DFA. Let us check if it is complete. In A, I have mentioned what happens when it gets 0 and 1. Yeah, A is complete. B also I have mentioned what happens when it gets 0 and 1. B is complete. C also I have mentioned what happens on getting input 0 and 1. So C is also complete. So now we have made the equivalent DFA for this above NFA. And this is how you convert a NFA to its equivalent DFA. So I hope this was clear to you. And thank you for watching, and we will